Back, Elementary 31, Radicals and Introduction. Problem 1. Simplify the numerical expression negative square root 100. So notice the negative is outside, so it continues to stay. Square root of 100 is 10. So negative 10 is your answer. Next. Change the radical into simplest radical form, a square root c, where a and c are integers. 3 times square root 9. Now this requires some work. So let's look at it. 3 times square root of, 27. 3 times square root of 27. Now, square root 27 is not going to be a rational number or a whole number. So let us extract the most we can. 27 is 9 times 3. You see? So that is 3 times. What is the square root of 9? That's 3. And what is the square root of 3? Well, I cannot improve that. So square root of 9 is 3. Square root of 3, I cannot improve it. So it stays inside the square root. So that is 9. That's 3 times 3. Square root 3. So 9 square root 3. A is the outer number 9. C is the inner number 3. All right. Let's shrink this page so we can see both pages. So C is 3. Next. Okay, negative 5 square root of 27. Well, it's a similar question. You have negative 5 square root of 27. That is negative 5 square root 27. Well, let me extract the most I can. 9 times 3. So that is negative 5 times square root 9 is 3. Square root 3 I cannot improve, so I will leave it as square root 3. So whatever I could resolve, I resolved. Whatever I cannot, I leave it. That's the point of such problems. So here you have negative 5 times 3. That's a negative 15. And square root 3, I cannot improve, so it stays inside. All right. So A is the outer number. That's negative 15. And C, which is the inner number, that's the radicand, it is 3. Okay. Next. All right. Whoa. All right. There is a lot of description. I don't need to go over them, but let's go over each of these questions, right? So, you have square root 32. So remember, the point is to extract as much as we can out of 32. So, what is 32 going to be? Well, it is 4 times 8. I can do better than that, can't I? It is square root 4 times 2. You understand? So I need to keep getting more and more perfect squares inside. All right. If you see this, you immediately can see what was square root 32. It is square root 16 times 2. You see, I didn't have to write 4 and 4 and then 2. I could have simply written 16. Well, either way, what is square root of 16? 4. What is square root of 2? I cannot improve. So it is 4 square root 2. What cannot be improved stays inside. What can be resolved comes outside. So this is 4 SQRT 2. You understand? Square root is simply SQRT. Likewise, what about square root 27? Square root 27. We have seen this several times by now. This is square root 9 times 3. So that is equal, square root 9 is 3 and square root 3 cannot be improved. So that's a 3 SQRT parenthesis 3. Next, square root 18. What is that? That is equal square root 18 is nothing but 9 times 2. What is square root 9? 3. And what is square root 2? Well, we cannot improve. So don't forget, what resolved came out, what couldn't be resolved stayed in. So this is 3 SQRT 2. Next, square root 50, which is equal square root 25 times 2. So notice how we write perfect squares first. It's for reading purposes, right? Square root 25 is 5. Square root 2 stays inside because square root of 2 I cannot resolve. Square root of 25 I could resolve. So whatever you can resolve comes outside. Whatever you cannot resolve stays inside. So this is 5 SQRT 2. Next, square root 72. This might take a bit of work, but if you continue. So what is 72? Well, go through stepwise. If you notice, it is 36 times 2. That's the max. Okay, don't stop until you have gotten as much out as possible. Square root of 36 is 6 and square root of 2 cannot be improved. All right, so this is 6 SQRT 2. Then you have square root of 300. Wow, that's a huge number. But notice 300 is 100 times 3. So that is equal. Square root of 100 is 10. Square root of 3 I cannot improve, so it stays inside. So that is 10 SQRT 3. Likewise, square root of 24. Okay, square root of 24 is what? Well, square root of 24 is 4 times 6. Notice 6 is 2 and 3. Neither of them get you a perfect square root. So square root of 4 is 2. Square root of 6 cannot be improved. So 2 SQRT of 6. Next, square root of 420 equals square root. Well, looks like I can get a 4 out. 4 times 105. Can we improve 105? Let's see. Square root 4 times 105. 5 times 21. Can we improve 21? Let's see. Square root 4 times 5 times 21 is 7 times 3. Okay, none of these have whole number as square root. So square root of 4 is 2. The rest of them stay inside. 573. 573 is 5 times 21, which is 105. So 105 stays inside. So this is 2 SQRT 105. 375. I can already see what's going on. Square root of 375. Well, as you see, this is square root. Looks like 25 will go in it. 25 times, let's see, 25 times 4 is 100. So 8 will be 200. 12 will be 300. And 3 more. So that's a 15. So that is equal. Check my work, okay guys? 25 times 15 is 325. Oh, now square root of 25 is 5 and square root of 15 cannot be improved. So it remains as it is. 5 SQRT of 15. Square root of 96. Square root of 96 equals, notice 4 is a factor, 4 times 24, okay? So that is equals square root 4 times 24 has another 4, 4 times 6 is a 24. So notice 4 times 4 is 16 times 6 if you like. So that is 4. That is square root 16 is a 4. Square root 6 cannot be improved. 4 square root 6. Lastly, 27,000. Square root 27,000. That is equals, well, square root. Let me take care of the 100 first. 100 times 270. Make sure 2 zeros there, 1 0 here. Together gives me 3 zeros there. So that is square root 100 times, what about 9? 9 times 30, you see. 9 times 30 is 270. 30 on the other hand cannot be improved in the sense, if I break it down some more, 30 is 3 times 5 times 2. You see, 3 times 5, 15 times 2 is 30. So none of these resolve, right? So you have only these two. So let me combine them. 100 times 9 is 900 times 3 times 5 times 2, that was 30. Square root of 900 is 30. Square root of 30 cannot be resolved. So this is 30 square root of 30. All right. I think I will continue next problem in the next video.